purpose of this lab is to basically observe a simple energy conversion of one form of mechanical energy into another form of mechanical energy. In this case, specifically, potential energy into kinetic energy. Right? So those are the two things that we are comparing in this lab. Right? The lab will, by the way, I'm helping with the design part right now. Okay? So what we're going to be doing is, to start the lab, we're going to take the cart and we're going to lift it and we're going to place it near the top of the ramp. Okay? At which point it will have something that it won't have at the bottom. Or actually it'll have something like that but different. Okay? So we're going to compare values from the top to values at the bottom. And remember that the things we're looking at here is the conversion of potential energy into kinetic energy. Right? We only have to make really 3 measurements here. Okay? We have to measure the height for the start. Okay? Because we'll need the height to calculate the potential energy. Right? And the way we'll do that is we'll place the cart on the top of the ramp and then we'll measure from the floor to the center of the cart. Okay? You'll have to eyeball that a little bit, but that's where you want to measure to. The center of mass, so the center of the cart, is where you're going to measure your height to. And you're going to put the cart in exactly the same place on every trial. Okay? Now, at that point, you're going to start the SparkView app, and then wait till you see the line, and then let the cart go. Have someone at the bottom who's just going to stop it when it gets to the bottom, so it doesn't go off the end of the ramp. Okay? Stop it, and then stop the SparkView timer. The only thing you need to get from the SparkView data is the largest speed. Okay? What are we going to use that speed to calculate? The kinetic energy at the bottom of the ramp. Okay? The third thing you have to measure is the length of the ramp. Right? And the reason we need that is for one of the analysis questions. It's going to help us calculate the angle of the ramp as well as the distance over which work is done. Because, spoiler alert, the energy at the top and the energy at the bottom are not going to be equal. Why? Friction. Probably, yeah, I would say. And it's very likely friction that is going to cause the difference, because we're going to lose some energy as the cart goes down. That would be something you'd probably want to watch or observe, make maybe an observation about, is what do you notice as the cart is going down the ramp? Watching, listening, okay? Anything that could maybe show you the forms of energy that are being, let's say, released as the cart is going down the ramp, because obviously not all of the energy at the top, all that potential energy at the top is being converted into kinetic energy at the bottom. Okay? Now, there are some things that are going to remain the same each trial. Okay? And the only reason we're doing 3 trials is just so that we can limit our experimental error. Right? We're not comparing the 3 trials to each other. We're averaging the 3 trials. All right? So you'll calculate your speed at the bottom. You'll have your speed at the bottom for 3 trials, and then you'll just add them together and divide by 3 and get the average. Okay? By doing that, we eliminate if there was one trial that was maybe a little bit out. Okay? We're averaging it with the others. Right? Your height, that should be the same every single trial, so the average height is whatever you always put it to, okay, when you get to there. So that's why we've got this data chart that you're going to fill in. Okay? So you'll have whichever cart you're using, because that affects the mass, okay? And you'll have to measure the length of the ramp. From where you start the cart, the center of the cart, to the end. Okay? Everyone follow me there? Right. It's important that you don't just measure the length of the ramp, because the center of the cart is not going to travel the entire length of the ramp. All right. So that's all we have to collect in terms of data, and that's all we have to do in terms of variables. Okay, you think of what's going to be the same every trial. Okay, that could basically doesn't even have to be the same every trial, it just has to not change as the cart goes down the ramp. Okay, because we're really not comparing the trials, we just want to see how does the initial potential energy that we give it compare to the kinetic energy that it has at the bottom. Okay.
If nothing's changing the experiment because we're running the same trial 3 times, doesn't mean that nothing's the manipulating variable?
Nope, not at all what I'm saying. We're comparing two things. The two things we compare are always our manipulated and responding variables. Yeah? Yeah. Because if I don't do something with this lab, nothing happens. Right? If I don't put the cart at the top of the ramp, there's no experiment. Follow me there?
Yeah.
Okay. All right. So that's all we have to record. Okay, those 3 things. Okay, the height, the speed at the bottom of the ramp, and the length of the ramp. Those are the only 3 measurements we have to have. Okay, so how about we get all those, and then we got to talk about the hypothesis. Then we'll get all the data, and then we'll talk about the analysis. All right, so for the hypothesis, okay, what we're looking at for our hypothesis here in the if part, okay, needs to talk about what happens in energy conversions. So, you know, if, and we can talk about that this is in particular potential energy being converted to kinetic energy, okay? So in your if part, talk about what that looks like or what happens when energy is converted from one form to another, okay? The and part is going to describe the experiment. A cart's allowed to run down a ramp, converting potential energy into kinetic. Then, what are you going to see? Okay? How is your kinetic energy going to compare to the potential energy, and why? Okay? So in your if part, you might even want to talk about maybe like work energy theorem or the law of conservation of energy and what they say. Okay? So, you know, if the law of conservation of energy says that in this situation this should happen, and we do this, then this is what will happen. Or you can talk about if work energy theorem says that when one form of energy is converted to another, this happens, and this is done, then this is what will occur at the bottom. Okay? That's, you can kind of look at this from either point of view. We haven't talked much about conservation of energy yet, okay? But it should hopefully still be something you remember a bit from Science 10. Okay, questions before we set up our ramps and take our data? Okay, do the ramps need to be very steep? No. Nope. Okay, look at the one I built there. That's 3 of these textbooks. That might be, I don't know, 13 centimeters. Oh, do you want it in centimeters or meters?
Meters.
Meters. Holy smoke, was that close? That's like 12. Okay, now that's 12 just for the books. Where am I measuring to? Right to the middle of the cart. So we've been a little more to the middle of the cart. Okay, but you don't need it to be any taller than that. Okay, a couple of binders. Okay, something like that. That'll do. All right. Okay, let's get our data. That should only take about 5 or 6 minutes, and then we'll talk about the analysis. So obviously, when you're doing this and you're getting your full data set from the cart, it has everything in it. Okay? We don't need everything in it, right? In fact, we don't even really need the time, but I always keep it because it's kind of gives me a reference at least. So take out every column except for the time for run 1 and the velocities for your 3 runs. Okay, because that's all you need. Once you're there, so just stop what you're doing, guys, and watch up here. Once you're there, you'll have something like this, right? We're not actually graphing this data, so all we have to do is, you know, really look for the biggest number that's obviously reasonable for our experiment. Okay, so if I'm looking at my velocity data for run 1, I've got a negative 60.36 in there. Did my cart really go 60 meters per second? Not at any point. Certainly not at time 0, or it would have been flying up the ramp. Okay? Probably what happened is I bumped one of the wheels when I was putting it on the track. So I have to ignore the data that's obviously erroneous, okay? So what I'm going to look for here is that I can see where the cart for run 1 started accelerating, okay, 0.27, 0.31, 0.39, 0.4, okay, so I can see that kind of steady increase, and then it gets to 0.68, and then it drops. Okay, and then I've got all these weird numbers again that obviously are not true. They're probably, I stopped the cart and the wheels were off the end of the track and they were spinning really rapidly, okay, or something like that. So my maximum speed for run 1 is, I can logically assume 0.68. Okay, and when I'm looking at run 3, okay, my highest velocity there looks like about 0.65. That fits. My first run's maximum was 0.68. My second run should be pretty close to that number too, because we didn't change anything. Okay, and for run 4, I've got another one that's 0.65. So that fits. Okay, that's obviously my biggest number because there's no way it got going 37 meters per second at any point. All right, so that's all you're looking for. Okay, you need to get the maximum reasonable value for the velocity for each of your runs from the data, and that's it. That's all you have to do with your data. Okay? You're going to take that data and you're simply going to plug it in to the chart. Okay, so you're going to put it into this chart that you have, okay, speed, and then you're just going to add them up and divide by 3 to get your average. Right? For your heights, you should have dropped it from the same place every time, so you'll have the same number 3 times, actually 4 times, because that will also be your average. Okay? Once you have that data, then you've got your analysis. Question 1 in the analysis, calculate the potential energy at the cart at the top of the ramp, show your work. I want to see that calculation. It's a simple calculation, and I want to see it. Okay? Number 2, calculate the kinetic energy of the cart at the bottom of the ramp using your largest, or using actually your average value, okay, from the SparkView data. Right? That's a simple calculation. I want to see it. Number 3, did the potential energy of the system equal the system's kinetic energy? Why or why not? So there you got to compare the 2 numbers and tell me. Okay? Suggest reasons for whatever you get. Now, for number 4, okay, this is where there's some calculating, some Newton's second law, some work energy theorem stuff that comes into play. This is probably the tricky part of this analysis. Since friction does all the work in stopping or slowing the cart, and the cart's mass is known, what's the coefficient of friction between the cart's wheels and bearings? Because that's really where the friction occurs. Okay? We're going to simplify that and say it's basically between the cart and the ramp so that it works like an inclined plane. Right? So the tip I will give you here is this. You know the length of the ramp because you measured it. You also know the height of the ramp because you measured it. With those 2 numbers, you should be able to get the incline of your ramp. Okay? You also know the mass of your cart, which is acting as the mass that was on the plane. There's a difference in your energy between the top and the bottom. That would be your final energy, which is your kinetic, minus your initial energy, which is your potential. The question tells you that it's friction that's causing that difference. So what you really have here is the force of friction times the distance equals your change in energy. From there, I want you to calculate the coefficient of friction for this ramp cart system. I'm looking for mu. Okay? So from there, that's the work energy theorem. Okay? You'll have to, from there, figure out mu. So you'll have to do some inclined plane stuff from there in order to get that coefficient of friction. Right? That part, from there, I need you to figure out. Okay? I think I've laid out pretty much where to go, but you guys will have to figure out the steps to get there. Okay? The other analysis questions
okay, are pretty straightforward, but they're going to require you to do a little bit of writing. Okay, what can this lab tell us about the efficiency of mechanical energy conversion? So basically, when you look at those two numbers, are they really different? Or maybe even do this. Okay, take your final energy, so your kinetic, divided by your initial. That will actually get you your percent efficiency. Okay, then you can tell me, like, do you think that's a good energy, an efficient energy conversion, or an inefficient energy conversion? I mean, your cart only traveled the length of the ramp. How much energy did it lose over that length? Is that, what can that tell you? Okay, and then in number 6, what would be some ways to increase the efficiency of that energy conversion? Okay, and you can give me some ideas there. Then, same as always, conclusion and 2 sources of error and ways to fix them. All right, questions from you guys? So there's really not much to do. You guys should be able to get most of it done here, because you still have over a half an hour, almost 40 minutes.